What is 1/2 factorial? Honestly, 1/2 factorial makes no sense to me, because what does it even mean to count the number of ways that you can arrange half of an object in a line, right? And moreover, this notation is rather ill-defined. I mean, you get it from this definition of something called the gamma function, where gamma of n is equal to n minus 1 factorial. But this definition only holds for positive integers n, not for 3/2, which is what you would plug into n to get 1/2 factorial. But let's suppose we put all that aside. How do we actually find the value of 1/2 factorial? Well, we can use the gamma function, which is a very common way of extending the factorial function to complex numbers. In fact, the gamma function can be defined with this convergent improper integral, as long as the complex number z has a positive real part, which the complex numbers of 3/2 and 1/2 will satisfy, which will be relevant in a moment. In addition to this integral, we're also going to use this rather nice property of the gamma function. Gamma of z plus 1 is equal to z times gamma of z. Notice if we plug in 1/2 for z, we get gamma of 3/2 is equal to 1/2 times gamma of 1/2. So all we need to do to find the value of gamma of 3/2 is find the value of gamma 1/2. So if we plug in 1/2 into the integral definition of the gamma function, we get the following integral. The integral from 0 to infinity of t to the negative 1/2 power times e to the negative t dt. We can use a substitution here to simplify the integral, namely the substitution u equals t to the 1/2 power, or the square root of t. Taking the derivative of both sides, we get du is equal to 1/2 root t dt. Notice that root t is basically u, so making that substitution back in, we can see then, after simplifying, we get 2u du is equal to dt. Now, also notice that if we go back to our original substitution equation, if we square both sides, we get that t equals u squared. So if we put all of that together, if we plug in everything into our original integral simplifies to this. Take note that we should also adjust the bounds, but it turns out the bounds will stay at 0 and infinity in this case. So to find the value of the gamma function at 1/2, we have to evaluate this integral now, the integral from 0 to infinity of 2 times e to the negative u squared du. But since e to the negative u squared is a continuous even function, we can actually rewrite this integral as the integral from negative infinity to infinity of just e to the negative u squared, which is of course the infamous Gaussian integral, which is well known to be root pi. So plugging in root pi into gamma of 1/2 in our gamma equation, we get that gamma of 3/2, or 1/2 factorial, is equal to root pi over 2, which is about 0.886, which matches what our calculator showed us at the beginning of the video. So I hope that made sense. Make of it what you will, what 1/2 factorial means. But in any case, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch you all in the next one. Take care.